So, in the last lecture we discussed about one of the numerical method which can be easily used for multi-degree freedom system to find out the fundamental frequency, which was given by Dunker-Lee about 100-150 years back. Though it is an approximate method, it is very interesting to know that this method converges to the fundamental frequency with respect to the values worked out with the latest numerical methods, where you can find out all omegas. Now, there are some discrepancies, or there are some let us say unacceptable statements in Dunker-Lee's theory, saying that the Dunker-Lee's theory will give essentially only the fundamental frequency to an approximate value, because it assumes that the system behaves or is in a linear mode of operation. 1. 2. It does not give me the mode shapes, which are very important, because as I told you in the beginning also, even in classical eigensolver problem, if you do not know the mode shape, it is very difficult to converge whether the given mode is fundamental or higher modes. It is very difficult, because you have to always know how many zero crossings the mode shape has, because mode shape is actually the relative displacement of mass points under the given accelerating force or the inertia force of mx double dot. So, looking at the displaced position of the mass at lumped positions, one can easily converge and say yes, the mode is related to the first mode of vibration, second mode of vibration, and so on. Therefore, since the Dunker-Lee's principle does not establish anything about the mode shapes, it is very difficult to confidently converge that the frequency given by Dunker-Lee is addressing the fundamental frequency. Now, the problem becomes more serious when you have got closely spaced modes. There are structures where the first and second frequency will have a very marginal difference, very marginal difference. They will be sweeping successfully when you vibrate the system experimentally. You will not be able to actually capture. So, these systems or these solutions can be applicable to systems where you have got distinct band of frequencies, where the omega 1, omega 2, omega 3 are distinctly and explicitly different. But you have got a continuous mode of vibration, let us say omega 1, omega 2 are very close, and therefore, mode shape 1 and 2 will be successfully adapted by the system. It is very difficult to capture the fundamental frequency using Dunker-Lee, and it is very difficult to establish that the frequency given by Dunker-Lee is the fundamental frequency, because it does not address anything about the mode shape. Now, came in operation the numerical methods, out of which the most important and most fundamental method, which came in early 70s or let us say late 70s or early 80s, is the influence coefficient method, which we will discuss now. Influence coefficients are indicated by the letter alpha ij, and alpha stands for influence coefficients, and ij is the classical ith and jth terms in the given influence coefficient matrix. So, one should first understand what do you mean by an influence coefficient, and we will talk about this. Now, let us get back to the original equation. Let us say when the system vibrates in principal mode, one of the fundamental modes, it is under the influence of the inertia force. Quite naturally, this inertia force would be m1 x1 double dot. Why I am saying m1 and x1 double dot? Because it is understood that the fundamental mode will converge to an omega 1, and the modal mass or modal participation factor in the first degree of displacement will be predominantly present in the system. Okay. So, approximately it will have an influence, or the system will be under influence of inertia force. Therefore, the whole method will be now circumscribing under the influence of inertia forces on a given system. Now, let the displacement of the given system be harmonic. We can always assume an harmonic displacement. So, let xi be ai sin omega t, and we know that xi dot which can be written as of xi. So, the acceleration force which will be mass of this, under which influence the system is now vibrating, is nothing but a proportional multiplier of the displacement itself, and then multiply is nothing but the frequency. Okay. Having said this, we also know that delta, which the flexibility coefficient is inverse of stiffness, and omega square is k by m, which is now 1 by delta m. Hence, mi xi double dot, which is the inertia force under whose influence the system is vibrating, can be now considered as minus xi by m delta. I am borrowing this statement from here. Okay. So, therefore, minus xi mi xi double dot delta, because this can be related directly from here. Minus xi can be mi xi double dot of delta. I can expand this now for different degrees of freedom, minus x1, minus x2, minus x3. Let us say we will take a 3 degree freedom system model. We will expand this statement for different degrees, because these are going to be the relative displacements, which is going to be the first mode shape if omega converges to omega 1, and so on. So, I will use alphas instead of deltas, because that is the influence coefficient terminology given in the literature. So, I will use alphas. So, let me write this expression in expanded form. I will say alpha 1 1, alpha 2 1 and alpha 3 1, alpha 1 2, alpha 2 2, alpha 3 2, alpha 1 3, alpha 2 3 and alpha 3 3. M1, M1, M1. Why? Because this belongs to the first column. Similarly, M2, M2, M2. Similarly, M3, M3, M3. Simple reason being they belong to the third column, M3. They all belong to the second column of the given matrix of alpha, therefore, second column M2. They all belong to the first column, therefore, M1. And obviously, I am looking for the influence of the inertia force. So, mass of that acceleration, mass of that acceleration, mass of that acceleration. Now, it is very carefully written equation. Please understand this equation. The common confusion will always start. You have a representation of writing M1, M2, M3, no problem. The moment you see alpha 2 here, you will again say x2, x3 and x1, that is a cycle. So, please remember the equations are written in this form, that first you write down the columns of every influence coefficient vector independently, and if they belong to 1, indicate m1 x1 double dot, they belong to 2 m2 x2 double dot, they belong to 3 m3 x3 double dot. Because why m3 x3 double dot or why m3 m2 etc., we are looking for the influence of the entire system under the inertia forces. That is why it is called influence coefficient method. So, these are nothing but the influence coefficients. Now, you can see here very well the displacement of x1, x2 or x3, which is going to be the first mode shape if omegas will be the first frequency, then they are nothing but proportion of the acceleration components from x1 double dot, x2 double dot and x3 double dot. That is why it is called influence coefficients. They gain the influence of every inertia component on the given displacement at every mass point, namely x1, x2 and x3. That is why it is called influence coefficient method. So, now I can write this influence coefficient separately as a matrix, just plug it out from here, which I call as an alpha matrix, which can be 3 by 3 if you have got 3 degrees of freedom, and of course, the mass matrix for this particular problem can be written again as a 3 by 3, and obviously since the mass matrix may be always generated in such a manner that the degrees of freedom will be marked at the same point where the mass is lumped, it is going to be a diagonally dominant case, and we can enter the mass matrix. So, now we will take up this algorithm and apply it on an example and derive the influence coefficient matrix and the mass matrix for a given problem. Now, please understand, in this case one may wonder, sir, omega is actually a function of k and m. Okay, m is available here, but why we are not having k? Okay, we are trying to find out the influence of the inertia force directly. Indirectly, the alpha matrix or the influence coefficient matrix is a representation of stiffness. Okay. So, k and m are present, but k is present here indirectly, right. Of course, m is directly present here. So, we will take up a problem now and try to derive the alpha and the mass matrix for the given problem, then we will solve the problem. So, our aim is to find out the eigen vector and the corresponding eigen value. On the other hand, to get the frequency and the corresponding mode shape for all frequencies and all mode shapes for a given n degree freedom system model, which was not available in Tankerley's proposition. Okay, that is the idea. So, we will take up this problem and see how this can be expanded. So, any questions in the algorithm here? So, one should know how to write this set of equations, then I will apply it, then you will be more comfortable. So, they are written column wise, row first and column next, row first and column next, second column, third column, and so on so forth, and all will be the inertia forces which on whose influence the system is vibrating at x1, x2 and x3 displacements for a given omega. So, all this or this vector now will be actually an eigenvector if omega corresponds to eigenvalue. So, now in this equation omega is not appearing, but omega is there indirectly. Okay, I will just place it here, you will come to know how we are getting extracting omega from this. Okay. So, let us take an example and try to derive alpha and m. So, the example is like this. So, as usual I want to derive the influence coefficient, which is nothing but the inverse of the stiffness matrix. We must give unit force at this location, this is x1. The second case could be give unit force at this location, force is unity, and the third could be give unit force at this location, and check what would be the restoring forces. So, look at a specific case of sub number 1. When I give an unit force here, the restoring force will be obviously equal to, we know that stiffness is force per deflection. I have given unit force here. So, I must find out the deflection, which will be the stiffness of this. So, in this case it is going to be alpha 1 1, let us say. Why 1 1? I am giving unit force at the first degree and finding the response at the first degree itself. So, alpha 1 1, which is going to be 1 by 3k, because 3k is the stiffness of that spring. And the remaining two mass points 2m and m will subside automatically with the same amount. Therefore, I can say alpha 2 1 and alpha 3 1 will be also equal to 1 by 3k, because they will be pulled down by the same amount. When I talk about the second subdivision here, giving unit force here, now we know that both these springs are in series. I can find an equivalent stiffness of this. Therefore, alpha 1 2, alpha 2 2 and alpha 3 2 need to be found out. So, now I can understand that the springs 3K and K, these two, on the other hand these two will be in series. So, one can work out an equivalent stiffness of this. So, 1 by K equivalent 1 by 3K plus 1 by K 4 by 3K, or K equivalent is 3K by 4. So, alpha 2 2 will be 4 by 3K, alpha 1 2 will also be 4 by 3K because they are in series. Alpha 3 2, sorry, the next one, alpha 3 2 and alpha 2 2 will be in the same amount. So, they will be 4 by 3K, and alpha 1 2 will be as same as alpha 2 1 by reciprocal theorem, which already we have. Similarly, for the third case, the springs 3K, K and K will be in series. Hence, 1 by K equivalent can be 1 by 3K plus 1 by K plus 1 by K, 7 by 3K. Therefore, alpha 3 3 will be 7 by 3K, and alpha 2 3 will be as same as alpha 3 2, and alpha 1 3 will be as same as alpha 3 1, which we already have here. So, let us enter the alpha matrix here, which we want to have, which will be a common denominator of 1 by 3K. So, 1 1 1 1 4 4 1 4 and 7. So, it is interesting that this matrix is symmetric, diagonally dominant, whose inverse will now exist, whose inverse will be the stiffness matrix. Okay. So, alpha matrix is now generated, which will be used as a multiplier here for the given algorithm. Mass matrix of course can be generated quickly. It is going to be, this is the first degree, this is x1, x2 and x3. Therefore, 4m, 2m and m. And we all know why the off-diagonal elements are 0, because they are taken at the same point where the mass is lumped. The influence coefficient, which is as same as the delta matrix, I have the leading diagonal values, I have the mass values. I can easily find the Dunker-Lewis frequency for this. Can you find out the Dunker-Lewis frequencies for this? It says 1 by omega square m1, let us say alpha 1 1, m2 alpha 2 2, m3 alpha 3 3. We have all the values with us now. You can easily find out and tell me what is the value. What is the value of omega? Yeah. Is 1 by omega square, that is how you get k by m. Let me apply this algorithm now for influence coefficient method. I will write down the alpha matrix here because I may require it. I may require the mass matrix also. So, minus x1, minus x2, minus x3, alpha 1 1, 3 1, the common mistake what people will make is they will write m1, m2, m3 here. Okay, that is why I am saying please remember the first column represents the first mass, the second column represents the second mass, all other terms will be 0 because mass matrix is diagonal. Let us substitute it here. I will call this equation set as 1, the full set. So, minus x1, minus x2, minus x3, alpha 1 1 I already have, here retain it as it is, alpha 1 1, alpha 2 1, alpha 3 1, alpha 1 2, alpha 2 2, alpha 3 2, alpha 1 3, alpha 2 3, alpha 3 3, m1 is 4m, m2 is 2m, m is as m3, I have to write x1 double dot, x2 double dot and x3 double dot here. We already know x1 double dot can be connected to x1 by a relationship which is minus omega square x1. Okay. So, I can write here minus omega square x1 instead of x1 double dot, assuming an harmonic excitation. So, minus omega square. Similarly, minus omega square x2, minus omega square x2, minus omega square x2, minus omega square x3, minus omega square x3, minus omega square x3. The whole expression, the negative term goes off. I can rewrite this equation set in a matrix form like this. Okay, I will write it here. x1, x2, x3, which is a vector, which will be omega square m by 3k. I am getting m from here, I am getting omega square from here. The denominator of 3k is alpha coefficient where I have it here, okay, which is now going to be alpha 1 1, 2 1, 3 1, alpha 1 2, 2 2, 3 2, alpha 1 3, 2 3, 3 3, with a multipliers of 4, 4 and 4, 2, 2 and 2 and 1 1 and 1. Multiplied by x1, x2, x3. Now, just read one line of this equation. x1 will be equal to omega square m by 3k 4 alpha 1 1 x1, 2 alpha 1 2 x2, alpha 1 3 x3, which is as same as here. x1 is equal to omega square m by 3k, that is the denominator here, of alpha 1 1 x1 plus 2 alpha 2 2 alpha 1 2 x2 and alpha 1 3 x3, which is available here. So, I have transformed the equation set into a matrix form like this. Now, you may look at this equation. This equation has got both sides a vector which is not known to me. What I know in this equation is the matrix and of course, the k value and the m value. I do not know because k value is a known factor here. The stiffness spring is known to me, k and m are known to me, but I neither know omega nor I know the vector. Once you have any algebraic equation which has got LHS and RHS of the same unknown, the best procedure to solve this is iteration. You assume a scheme, assume a vector and keep on substituting the vector for the left hand side and multiply it, get a new vector, compare the new vector with the assumed vector and keep on doing this exercise until the new vector and the assumed vector converges. Okay, that is the best scheme to do in any numeric integration like this. So, let us try to do that numerically and see how we can solve this. So, this is my scheme available to me now, which is equation 3 in a matrix form. I must assume the vector. Now, the question is how will I assume this vector? One can start all as 1, one can start 1 0 1 and so on. Now, the question is what will be the relevant value of assuming this vector? Now, this problem is actually more focused on the type of mass concentration on every degree of freedom. But one thing is very certain, I am first attempting to look at the fundamental frequency of the problem. The moment I say I am attempting to look at the fundamental frequency of the problem, I must always know that the vector will have all positive numbers or all negative numbers. So, there is no zero crossing in the given vector. The vector should not have any zero crossing. Therefore, 1 0 1 will not work out. When you plot 1 0 1, you will always have a vector crossing at 0. So, I do not want any other number plus and minus mixture because I want a 0 crossing here. Why? I am attempting to look at the fundamental frequency which is the capturing point of my problem. Therefore, I must take all positive. To start with, you can say 1 1 1, keep on iterating. The one good thing about this algorithm is whatever vector you start with, provided you are logically correct, it will converge. I do not have time to demonstrate. So, I will take up 1 2 1 4. Please do not ask me how did we get this number of 1 2 1 4. Okay, I have taken it exactly from here 1 2 1 4. Okay, I have assumed it like this. You can also start with 1 1 and check, it is going to converge automatically with the same value. Then you may ask me, sir, 1 2 1 4 vector is not algebraically equal to 1 1 1 vector. Please understand, mode shape is a relative displacement of the mass point. I can always take a multiplier out and then I give the vector which is going to give the same meaning, right. Let us see how it is there. As long as all vector points are positive, as long as the vector denotes the first frequency, our answers are all right. Okay. So, 1 2 4 I have started with omega square m by 3k will be the multiplier. Even though I have a value of m and k, maybe m is 100 kg, k is 100 Newton per meter, do not have to multiply it at this stage here. Leave it as an unknown value which can be substituted later, okay, because do not get complicated by multiplying this and having a fraction on the left hand side of this equation. It is not required. Let us have this equation of 4 alpha 1 1 is what is the value. So, can I write here simply as 4 4 4 alpha 1 1. Similarly, the next one is alpha 1 2 twice of alpha 1 2. So, I should say 2 8 and 8. Okay. The third column will be 1 4 and 7 multiplied with 1 2 4. That is what I started. So, now I will get a value when I multiply. You see here, this is 3 by 3, this is 3 by 1. So, I will get a vector now which will be a new vector. This vector if fortunately becomes same as this, then my convergence is already achieved. But let us see what is the vector I am getting. Multiply this and tell me what is the vector I am getting. So, anyway I have a multiplier omega square m by 3k here. I take 12 out because it is 4 plus 4 8 plus 4 12. I take 12 out, therefore I get 1 here. Be happy because I have 1 here, I have 1 here also. Okay, let us see what happens to other numbers. So, this is going to be 4 plus 4 8 plus 4, okay, 4 plus 16 20 plus 16 36. So, this becomes 3. This is going to be 4 plus 16 20 plus 28 48, it means 4. So, I have started with 1 2 4 landing in 1 3 4. So, it is not right, therefore, let me start again with 1 3 4. Now, there is a very important statement here. For example, you started with 1 2.1 and you are getting 2.2 here, let us say. Do not try to go back in between because the convergence is continuous. If you jump the step, you will never get converged. So, you have got to compulsorily borrow the same vector and do it. Okay? So, 1 3 4 omega square m by 3k of the same matrix of 1 3 4. Give me the new vector quickly, omega square m by 3k of some multiplier of, this multiplier is going to be 14. Okay. So, 1 and 4 are matching, but the number 1 is not matching. Therefore, let us do 1 3.143 of 4 with omega square m by 3k of the same matrix of 1 3.143 of 4, and I get omega square m by 3k multiplier of some vector 14 2 8 1 3.16. So, let us check again with 3.16 because 3.1 we have converged. Let us go for the next digit also. So, let us try with 3.16 on the left hand side and see whether it is converging. So, you must check whether I am getting the same vector back. Here the multiplier will change because it is 3 of so we have converged. Okay. Now, I will tell you where are the mistakes what people generally commit. The first mistake what you will commit is when you are writing the governing equation to form this matrix, you make an error. I told you very deliberately it should be alpha 1 1 2 1 and 3 1. The first column means m1 x1 double dot, second column means m2 x2 double dot, third column is m3 x3 double dot. Therefore, that error should not be there. Once you practice number of times, you will not do that error. The very common and a very psychiatric mistake what people make is they take this multiplier and put it here. Okay. Please understand, I am not bothered about this multiplier at all. I am only bothered about the relative displacement of the mass. Once you have this point in your mind, you will only pick up this and get this back again. So, this number will be keep on changing. The third issue is, if it is progressively increasing, it will increase. If it is progressively decreasing, it will decrease. If it increase and decrease, you are missing a mode shape in between somewhere. So, your assumption is wrong. So, this method is having some self check also. You see, this progressively increasing means it will increase. No minus and plus will be changing, right. So, you have to be very careful in that. And the fourth issue is how to get this vector in the start. Had you started with 1 1 1, what would have happened? So, I think you should experience that, you will know what would have happened. You will end up in the same vector with this. Now, the question is, how do I get me omega from this? Okay. So, just read this equation, the left hand side is equal to the right hand side. Can I say algebraically 1 equals omega square m by 3k of 14.32 of 1? Can I say this? From this I can easily find omega. So, what is omega? Some value of k by m. 0.457 k by m, whereas if you compare this quick value with the Dunkerley, it was close to 0.4, 0.397, it's close to 0.4. So, after doing so many mathematics you got a number, whereas Dunkerley came close to this number in minutes. Okay. So, that was the idea and that was the efficiency of the method proposed by Dunkerley earlier. Okay. Now, I am not interested in going to stop at omega 1 and phi 1. My job is to find omega 2 phi 2, omega 3 phi 3 also. Okay. I already told you that once you start finding out the higher modes, it is always better to find the orthogonal modes automatically, because then you get an advantage. In the previous example, what we did in eigensolver is you found the modes in vectors, you found to be they are non-orthogonal, you diagonalized or you orthogonalized them by a multiply with respect to mass matrix. Now, in this case I will automatically set an equation to derive the orthogonal vectors automatically. So, whatever vectors I will get, they will become automatically orthogonal. Okay. So, we will see that in the next lecture. So, there is a small take home assignment for you. The take home assignment is very simple. For this problem, try to write down the equation of motion, try to write down the equations of motion, try to find the mass matrix which you already have with me, try to write the stiffness matrix which you already generate, and take an inverse of this and check is this inverse same as that of the delta matrix what you got. Okay. So, that is an assignment for you, and the second assignment could be start with any positive vector and see is it really converging or not. Are you getting the same proportional displacement like this? Okay. Then one may ask a very interesting question here. The question is very clear. If the displacement is not exactly proportional to this number, this multiplier will keep on changing. I will get 14.32, you may get 15.55, she may get 14.86. On the other hand, for different people one should get different omegas. The answer is not that. You will get the same multiplier with the same fraction whatever you assume here. That is, you please check and tell me is it coming out or not. So, the omega and corresponding phi will not change, it will not change. Okay. So, if you are not able to understand this, you must go through the algorithm first. How did you derive this algorithm, and try to practice yourself to write the equations. I would urge you to write the equation same manner as I wrote on the blackboard. Do not write row wise, write step by step like this. That is how this equation can be done without any error. Okay. This is one of the easiest possible computer methods to find all eigenvalues and eigenvectors, where many software follow this method only. The only difficulty in this method is to start with the vector. Okay. Generally softwares have a program where the vector will be multipliers of m ratios. If all m's are almost equal in a given multi-story building or a given platform, then you will start obviously with 1 1 1 and you will always start only with the positive node. The another advantage of this method is, depending upon your choice, you can always get either the first frequency or the highest frequency also, because it all depends on how do you assume a vector. Whereas Dunkerley will always give you only the fundamental frequency. So, since I assume a vector all to be positive, I am claiming that this will be the natural frequency. I will verify this only after I get all the frequencies and mode shapes, then we will confirm. Now, we presume that it should be the natural frequency, but all you care, you may suspect that the next mode can also be all positive. We do not know actually, let us try. Okay, well, let us try, examine, write all the vectors, and then we will confirm, yes, this is my only positive vector, therefore, this is my fundamental frequency. If it is accepted, then you should appreciate, for finding this as a fundamental frequency, you are supposed to do all the omegas and phis, whereas Dunkerley did not do any such exercise. He simply said pick up the value, get the value, it will be only the fundamental frequency. Now, Dunkerley's proposal in 1859 was not supported by algebraic definitions that it will converge to fundamental frequency, therefore, it was not popular. I will show you a mathematical proof subsequently in some lectures where always it will converge to only fundamental frequency. Mathematically I can prove this. In an algebraic equation set I can prove, then Dunkerley's value would have been more appreciated. So, this method is also sometimes called as matrix inversion method. Okay. In literature they call it matrix inversion method. Some authors call them as matrix method. Okay. Essentially the original name given to this method not by me, the authors are influence coefficient method available in the literature, because the whole system is under the influence of inertia forces. That is why the whole equation is circumscribed under the influence of M1 or Mi xi double dot, that is the reason. And this equation sets principally assume that the structure undergoes an harmonic linear excitation, okay. That is an assumption in the system, and this can be applied to any n degree of freedom models, provided you are able to multiply the matrix easily. The most advantageous procedure in this method is, this method will not demand inverse of a matrix at all. Inverse of a matrix is the most difficult task in matrix algebra, okay. It is not only true with me, it is true to all of us. Inverse is always dangerous, okay. This method will never ask you to invert, it asks you only to multiply. If you have problem multiplying also, you should stick on to Dunkerley only, you can't help. So, there is no inversion required, and people generally have confusion in deriving flexibility matrix, okay. What they generally do is, they are very good in stiffness matrix, they derive the stiffness matrix and take an inversion. When they take an inverse, they make mistakes. So, this method indirectly delivers a flexibility matrix for you, which you will verify as a take home assignment and see is it true or not, okay. So, that is why it is called, this method has got lot of advantages, easily programmable. So, I would urge that at least few of you or at least all of you should write a computer program and try to run this for n degree of freedom, parallelly check for Dunkerley etc. When at the end of the lectures you should have a coding which intakes the mass and stiffness values in n degrees of freedom, and instantaneously I must get omega and phi by at least 5 methods. I can compare and give a percentile error immediately in minutes, which a software can do after you do a mathematical modeling of this in the software. So, which you can do. So, this is a very handy tool for research people. If you really wanted to know what are my lower band and higher band frequencies in a given geometric form, which is non-standard form, this method is very helpful. So, you need not have to invert a matrix, you do not actually form a matrix at all, except that you have to only understand the fundamental system of equations and simply multiply, and within minutes you will be able to get the omegas and phis, all omegas and all phis, okay. The most advantageous method in this case is, it will give you omega and phi sequentially, it will give you omega 1, then omega 2 and omega 3, that is the beauty of this method. So, this method is appreciable by lot of, and even today this method is valuable, because if you want to really resolve omegas and phis by hand, this is one of the easiest tool you have. There are many other methods, every method will have merits and demerits. There are demerits in this method also, I will come back to that at the end, okay. There are demerits in this method, we will see that later, okay. As of now this method is very advantageous for us, and let me tell you how to find omega and phi in the higher order in the next class, okay. Any questions here? So, try to do this take home assignment and try to verify whether it is converged at 111 and see what is the difficulty you have, and start writing coding either in MATLAB or in C++, any language coding you know, try to start doing the coding now, so that you at least have the solution ready. The moment the problem is posted on the board, you will have the answer instantaneously. We can check the answer on the blackboard parallelly with the solution given by the program, okay. Thank you.